Hi guys, I'm NK. Welcome to our family. In today's lecture, we are solving out the question related to the differential equation. Question says that solve the following differential equation: d square minus 3d plus 2 into y is equal to cos hyperbolic x. Solution. Let us write down here auxiliary equation in short form it is write down AE is. For finding out the auxiliary equation, put the capital D is equal to M. Then we get M square minus 3M plus 2 is equal to 0. It's a codic equation. It may be solved out by splitting of the middle term, may be solved out by squaring method, may be solved out by codic formula. When we solve out by the splitting of middle term, we get minus 2m minus m plus 2 is equal to 0. Plus 2 is equal to 0. When we take out m as a common, we get m minus 2 minus 1 as a common in last two factor, then m minus 2 is equal to 0. It's a codic equation, so we get two factor and two roots, that is m minus 2 and m minus 1. Both are the factor of a given equation is equal to 0. So m is equal to 2 is the first root and another one is 1. Now CF is equal to hence CF is equal to, we know that when two roots are unequal, CF is given by C1 e the power ax plus C2 e the power bx plus C2 e the power bx. Now Pi is equal to Pi stands for particular integral. Pi is equal to, for finding out the Pi, write down the RHS part of the given equation in numerator cos hyperbolic x. Cos hyperbolic x upon the LHS part of d square equation is given in denominator, that is d square minus 3d plus 2 minus 3d plus 2. Now we know that the cos hyperbolic x is can be written as cos hyperbolic theta is equal to e the power theta plus e the power minus theta upon 2. So we can write down Pi is equal to Pi is equal to e the power x plus e the power minus x upon the 2 is in denominator, then 2 is in denominator upon 2. D square minus 3d plus 2 in the factor form can be write down d minus 2 d minus 1 d minus 2 and d minus 1. Now when we write down the separate, we get Pi is equal to e the power x upon e the power x upon 2 into d minus 2 d minus 1 plus e the power minus x upon 2 into d minus 2 d minus 1 d minus 1. Now apply the identity of e the power ax, that says that if e the power ax is given in denominator and the function of d is given in denominator fd, then we can write down e the power ax upon fa, but fa not is equal to 0. fa does not equal to 0, because if fa is equal to 0, it's become a infinite form, undeterminate form. So pi is equal to e the power x is as it is upon 2 as it is. When we put d is equal to, here a is 1, d is equal to 1 minus 2. When we equal to d is equal to 1 minus 1 is 0, so it's write down d minus 1, because 0 is not in denominator, plus e the power minus x upon e the power minus x upon 2 as it is. Here the value of a is minus 1, so minus 1 minus 2 minus 1 minus 1 minus 1. Now we again solve out, then we get pi is equal to e the power x upon minus 2 into d minus 1 and the second term is plus e the power minus x, 3 2 ja 6, 6 2 ja 12, e the power minus x upon 12. Now solve out. Again apply the identity. Identity says that if e the power ax is given in numerator upon d minus a the power n is given in denominator, then we can write down x the power n upon factorial n into e the power ax Now the solution is pi is equal to minus 1 by 2 into x the power n. So x the power n is x the power 1 into e the power x plus e the power minus x upon 12. Now complete solution is given by, complete solution in a short form it can be write down CS. It's also known as a general solution. CS is equal to CF plus PI. Now y is equal to CF is C1 e the power x plus C2 e the power 2x. C1 e the power x plus C2 e the power 2x minus x by 2 e the power x plus e the power minus x upon 12. That is our complete solution. C1 e the power x plus C2 e the power 2x minus x by 2 e the power x plus e the power minus x upon 12. That is our complete solution. I think you understand how we can solve out the given question by the using of algebraic identities and the auxiliary equation. Now our lecture is finished. Jai Hind, Jai Bharat.